the cloud, and we want to do normal distribution, normal distributions problem, normal distribution. So we solved many types of problem. Now we want to solve minus 2z less than a equal to 0.69. Okay. Then what is a? What is a? Okay. What is a? This is the question. How can I find the value of a? So let me draw the graph. This is what we have. Normal curve. This is 0. Left side of 0, we have 50%. Right side of 0, we have 50%. Okay. So this is the z value. In this line, we have z values. Z values. In this line, we have z values. In this line, we have z values. Under this bell-shaped curve, above this horizontal curve, we have 100% frequency. Okay, 100% area or probability. Okay, so now I am given -2. So this is my -2. Okay, this is my -2, and then a -2 to a equal to 0.69. Are you understanding? -2 to a equal to 0.69, right? So my question is, a should be in here or a should be in here? That boy, quiet boy. Where a should be?
I was going to say to the right.
To the right. Why? Why? She said a should be in here. A should not be in there. Why?
Because it's positive. So,
It positive what? 0.69?
yeah, 0.69.
Any other explanation? Yes.
Don't they mirror each other, so that -2 for the -0.69 and the +2 is positive -0.69.
Okay, so let me explain these things then. This is 50%, right? And that is
50%.
so in order to have it here, it should be must be less than
50.
yes. Do you understand? This area equal to what percent? This area equal to what percent? 50%, right? Take another color. That area equal to what? 50%, right? So in order to have a in here, then here to a, so that means this area that must be less than 50, right? Do you understand? That is the rationale, but we have what? 0.69, right? Which is bigger than 0.5. So it should be in there. So we have to draw the figure like this way. And this is my A, this is my -2, and this is the point. This is the 0.69. Do you understand, people? Do you understand? So that is the 0.69. My purpose is to find A. Clear, right? What is the value of A? My purpose is to find A, right? A. This is the problem I always give in the exam. Okay, so that means I give you 2 points. I give you 5 points. This is the type of problem I always give in the exam. Okay. Now, can any one of you help me? How can I find the value of A? What I need to find first? Can any one of you tell me? Yeah.
But we need to find A on the Z table.
Yep. I have to find A on the Z table, or I have to write R or Python programming code. Last time we wrote Python programming code. You remember? What code we wrote last time?
So it's stats.norm.ppf.
Yeah, right?
Yeah.
So then I do not know this, so I have to find that one. Okay, how can I find this area? Do you understand? Do you understand? I have to find this area, right? That area equal to what? Probability of z less than -2. Okay, so what Python code I can write? Can any one of you help me? Let me open the Python Anaconda. This one. Open Anaconda. Anaconda, why are you taking log line?
My internet's been slow
Okay.
always.
So let me open the what it called normal table. Normal table PDF. Normal table PDF. It's a normal distribution area to the left. Is this the normal table? Let me see. Yes, yes. We found a normal table. Are you seeing this value? Point less than -2, right? Less than -2 equal to what? 0.02275. Right, right? Are you seeing that? 0.02275. 0.02275. 0.02275, right? So I should go there. I should write here what? This is equal to 0.02275. Clear, right? Understand, right? Okay. You can tell me now the Python code. Because I want to give you both. What happened to this? Okay. Here. Hmm. Yes. Okay. Tell me what should I write now? What should I write now? Last time, what did I write? Don't you have the Python code the last time that I write? Didn't I write Python code last time? So what should I bring? Import. Oh, it is already in there. Okay, so then what code I write? Stat dot norm, then CDF like this,
Or no, .cd.
dot CDF, and then I have to write -2, right? 0,1 like this.
Yeah.
Okay, so let me run this. Are you saying 0.0227? You can either use physical table or Python. Clear, right? You got it, right? Everyone getting it, right? So when you will take your next exam, which will be due not this coming Sunday, Sunday after this coming Sunday. Okay? Exam will be on binomial distribution, geometric, negative binomial, normal, and Poisson distribution, which I am going to discuss. 5. How many fingers? How many distributions? Okay? So they are, each time I discuss any theory, I also discuss real life problem, right? Go over those things. I will also discuss. Okay, so now we have these things. I have shown you how to compute these values. Now I want to add these plus that.
So the 0.0275 plus 0.69.
Yes,
Okay.
so that means 0.69. So what I am getting now? 0.0022275. If these two, if you add 572.7. Understand? Do you get it? You got it, right? So that area equal to what? This area equal to that complete area now. This complete area. This complete area. Including this area. Which is equal to that. Clear, right? So now how can I find the Z? Let me write this code. That code I can write in here so that you would not have a problem. That is states.norm.cdf. States.norm.cdf. By using Python, it is states.norm.cdf, then -20, 1. That's the way you have found that. This is the Python code. Clear? So now I want to find the value of Z. Who can help me to find the value of Z? This girl last time helped me. The code. Now I want to find the value of Z. See, I am finding the value of Z. I'm not finding the area because area is given. Area is this. I want to find the value of Z. Tell me the value of Z now. States dot norm dot ppf, right? ppf. Okay. Equal to 0.7127 71275 0, 1. Okay. So I will also show you how to find this by using the table. Let me go there. I want to just change it in here. Go there. I want to just change CDF to PPF. And then that value will be what? Can anyone of you tell me?
0.71257 or 5. Hold on. 71257
71257, right?
or 75, sorry.
What happened here? State norm PPF or PPF I wrote in a capital format. PPF. So 0.5609. 0.5609. Okay. So 0.5609. That is what we have equal to 0.5609. So that means Z value, that is here 0.5609. Online student Grace, are you understanding?
Yes.
Okay, good. Everyone clear, right? You look like you have a question.
What was it? Representative?
This one?
Yeah.
States.norm PPF. PPF means what? You are given probability or percentage or frequency, percentage given, and you are finding Z value. CDF means you are given Z value, you are finding probability. And PPF means you are given probability, you are finding Z value. Understand? So let me write here. CDF means you are finding probability or percentage or probability of percentage or area. Area under the bell-shaped curve above the horizontal line. And PPF means you are finding Z values. You are finding Z values. Okay. PPF means you are finding Z values. So everyone understand, right? No question, right? Clear, right? Everyone understand. So now if you want me, hey, professor, Python is developed just 1991, 92. How can I compute these things by using table? Understand your question? How can I find these values which is equal to Z by using table? Okay. In order to use the table, let us go to the, in order to find this by using table, let us go there. So are you saying this is 0.5 and then 0.72? Where is the 0.72? Here is the 0.72. So this is the 0.72. Our value was our value was 0.71275. 71275. Okay. 71275. 71275. 71275. 71275. So this is the closest value. 71275. Yeah, 71275. This is the closest value, right? Right. Are you seeing? So now I am looking inside the table. So 71275, and this is the closest one. Okay. Corresponding to that, our Z value 0.56, right? Right? So take a look at that. 0.56, right? Your question? You understanding? Yes or no?
Yes.
Good. Yes.
On a test or quiz, would you want us to use the table or the code?
Either one is fine.
Okay.
Code is fine because you are going to use the code ultimately. Okay. Something develop new, those things become old. Okay. You have to use the Python. Okay. So now, last class and today, I discussed what? This is the normal curve. Okay. Bell shape, mound shape, normal curve. This is, and there is a 50% 0.50. There is a 50% 0.50. This is the area and this is the Z value. Okay. What we learn, how to compute probability or area. Probability or area or percentage when Z values are given. Z values are given. Okay. This is one we have learned. And another things, how to, number 2, how to compute Z values when, how to compute Z values when, how to compute Z values when probability or area or percentage is given. Percentage is given. So from the normal distributions, okay, there are two types of problem altogether. Either finding area or finding Z values. Clear, right? So this is a Z distribution or normal distribution. This is called the Z distribution. Z distribution or normal distribution or Gaussian distribution. Gaussian distribution, okay, which has mean equal to 0, mean equal to 0, and standard deviation equal to 1. Clear, right? When a normal distribution, Gaussian distribution or symmetric distribution has a 0 mean and a standard deviation 1, then you have to compute this probability by plugging mean equal to 0 and standard deviation equal to 1 in the formula. Okay, so this mathematical formula which you do not need at all, but I have to write you to convince you this is the mathematical formula of this normal distribution of z square. Okay, this is the, you remember binomial distributions, I write a mathematical formula, right? Geometric distribution, I write a mathematical formula, right? Negative binomial distribution, I write a mathematical formula, right? And then we computed probability by using Python as well as paper and pencil approach, right? So this is the mathematical formula for the normal distributions. You do not need to be scared of by seeing this. Clear? Now, suppose mean is not equal to 1, sorry, mean is not equal to 0 and standard deviation is not equal to 1. Then normal distribution, it is called the standard normal distribution. This is called the standard normal distribution when mean equal to 0, when mean equal to 0 and standard deviation equal to 1, that is called the standard normal distribution. That is called the standard normal distribution. Okay, when mean equal to 0, when mean equal to 0, standard deviation equal to 1, that distribution is called the standard normal distribution. But when mean is not equal to 0, mean is not equal to 0, standard deviation is not equal to 1, then the distribution is called just normal distribution. Normal distribution. Okay, how the mathematical formula look like? Mathematical expression look like this. Again, you do not need to memorize any of these things. Sigma e to the power minus half sigma square x minus mu square. This is the mathematical formula of the normal distribution. Right? So the question is why I am writing this? Because when you find the probability from the probability table or Python, they are going to use these mathematical function in order to integrate and come out with that percentage value. Understand? Are you understanding? So down the road, you might have a question. Dr. Choudhury taught us how to use the table and how to compute this formula, how to solve this problem. But he did not explain how these probability are computed, what formula was used. So this is the formula was used. Okay, this is the formula was used. Now I want to solve a different kind of problem, which is known as the word problem. Word problem. Everyone ready? Word problem. How? Take a look. SAT scores are normally distributed with mean 550 and standard deviation 20. You see, normal distribution and mean has 550, which is different than 0, right? Right? And standard deviation is 20. Clear, right? A Macomb High School student took SAT exam, find the probability that his SAT scores is greater than 570. Number two, his SAT scores is less than 580. His SAT score is between 540 and 560. Also, find the the 93rd percentile. Also find the 93rd percentile value of SAT scores. Also find 93rd percentile value, 93rd percentile value of SAT score of SAT score. Are you understanding? This is real life. Suppose we have our salary. Salary is normally distributed. A randomly picked person salary is normally distributed with mean salary 50,000, standard deviation is 5,000. A randomly selected person has a salary greater than 60,000, less than 40,000, between 40,000. So in the normal distributions problem, these things must be written in the question, normally distributed. You understand? The word normally distributed must be in the question. But for the binomial, for the geometric, for the negative binomial, for the Poisson, there is no mention. By reading the question, you have to understand whether I am going to use negative binomial or Poisson or geometric or binomial. Understand? For the discrete distributions, where x take integer value 0, 1, 2, 3, 4. For those type of problem, for the discrete distributions, you have to identify whether you are going to use binomial or Poisson or negative binomial or geometric. But for the normal distributions, normally distributed word must be in the question. Clear, right? Okay, so now we have to solve this problem. So first problem solution. First problem is asking, suppose x equal to SAT scores of a Macomb high school student. Okay. So now first question is find the probability that his SAT score greater than 570. Do you agree with this? So this could be written 1 minus probability of x less equal to 570. Do you agree with that? Can I write this equal to that or not? Can I write this equal to that or not? Can I write? This is total probability equal to 1 minus total probability equal to 1 minus rest equal to give you the greater than 1 minus less equal to greater than total probability equal to 1, right? So greater than equal to 1 minus less than. The probability can never exceed 0. So now what you can do, the code that you have given, you just write like this. Excuse me. You will write here states dot norm dot CDF and then 570, 550 and then 20. Did you get it or not? So in this case, distributions looks like that. Let me write it in here. In this case, your normal distributions looks like this, but now mean at 550. Previously mean was 0, right? Are you seeing the graph now? 550, okay? Clear, right? And this is the standard deviation. Let me clarify one idea. So this is the one distribution, normal distribution. This is the 550 and this spreadness is give you the standard deviations. So that is equal to 20. Now I have another normal distribution in here, which is little like this. In this case, mean is still 50, but the standard deviation would be less than that. It could be 10. Do you understand? When it become, how can I say, or when it become very pushed, maybe squeezed in both sides, okay? You understand? When you push in the both side, then it is, so it will be further go down. Suppose this is a, like this, mean equal to 550, and this is the standard deviation, spreadness, which is equal to 5. Do you understand? The standard deviation means the spreadness measurement. If it's spread out, lot of deviations. Clear, right? So same normal distribution, same mean, but standard deviation is different. Okay? So anyone need any answer for this one? So this is what we are finding, right? This is equal to 570 and this is the graph. This is the area that you are finding. Are you okay? Are you understanding? This is the area that you are finding. This is the area that you are finding. Clear, right? Now, number 2, I want to find probability of X less than 580. This is equal to 580, right? So which I will write just states dot norm dot CDF. If it is less than, always use the formula. If it is greater than 1 minus, remember that thing. So then we have 580, comma 550, comma 20. Can any one of you tell me what was the number? Did any one of you compute that or not? Okay, if you did not, let me compute it. 1 minus 1 minus that one is 570 minus 550, 55 and 20. Here. 0.1586. 0.1586. 0.1586. Clear, right? Now that one would be 100. The next one would be just change it to 80 and take out the negative and minus sign. That is equal to 0.9331. 0.9331. 0.9331. You are understanding, right? These distributions has a lot of real life applications. If you study further and further and further and masters and PhD, you will see. And now R has the highest, Python has the highest number of user in the globe. So if you are very good in the Python, then if you write very beautifully in your CV that you are very good in data analysis, data mining, and statistical computation of test of hypothesis, correlation, regression, then your resume go up. Clear, right? For the final exam, what I will do, I will make a in-class exam, okay? But you are allowed to use Python. So write the Python code and maybe 10 questions is in there. Some questions coming from test of hypothesis, some coming from correlation, some coming from regression, and one problem or two problem from optimization, linear programming. Okay, don't get scared, easy, I will teach that. Okay, so you will come to the class and you will solve this. So for everyone is okay, right? Now I want to do the number 3, which is between problem. Between what? 540 and 560. So X is the ACT score. This is 560 and this is 540. This is what we want to find. Okay, this is 550 and this is 540. I want to find this area. Right? So what I need to do, I need to subtract this area. I need to subtract this area from this area. From whole pink area, I am going to subtract the orange area. Do you understand? Right? If I do these subtractions, then what I am going to end up? I'm going to end up with this one. I'm going to end up with this one. Clear, right? So let me do these things. So what I will do, probability of X less than 560 minus probability of X less than 540, which I can write states dot norm dot CDF, and then I can write here 560, 550, 20 minus states dot norm dot CDF dot 540, 550, 20. That's it. Okay. So let me compute these things. So what should I do now? I go there and I copy these things and I put here negative sign and Control V and then change it to 540 and then come here, change it to 560. 60. That's it. 0.3829. 0.3829. 0.3829. I solved 3 problems, right? And you have absolute freedom to solve this problem by using Python. Up until here, anyone has any question? Up to this point? Anyone has any question? If you do not have a question, I have a question for you. Let's see who can answer my. Okay. Suppose I do not have a Python. How can I compute this? Probability of x greater than 570, right? First one, I do not have a Python. And this one that you are seeing, this that you are seeing, this is in the Z format, right? This is not in the X format. First of all, try to understand. I do not have a Python, I do not have R, I do not have any machine. Okay? Clear, right? I only have Z table. But clearly there is written Z, right? This is Z value. That is also Z value after that decimal. For example, if someone want to pick this, this will be negative 3.61 equal to that. I do not have a computer. I do not have any machines. How can I compute x greater than 570? Yes.
Let's use the formula to change x to z.
Good.
The formula is, so it'd be 570 minus 550 over the standard deviation.
Yes, thank you very much. What she said, what you will have to do, use the formula. What is the formula? This is the Z formula, x minus mu over sigma. Okay, so what I did, x minus mu over sigma greater than 570 minus mu equal to 550 divided by standard deviation equal to 20. Now I have to change it to the Z. This is the formula. X now transform to Z. Okay, I have transformed x to Z divided by 20 over 20 equal to 1. So which I can write 1 minus probability of Z less equal to 1, which I can write like this. This is equal to 1. I'm subtracting this, which is equal to that, which will give us that. Are you understanding? Everyone understanding? So the question that I asked to you, I started the discussion with the Z table, and then I moved to the real life example of the SAT score, where SAT score is in the X format. How can I do the X format problem without using Excel? So this is the approach. Understand now? Okay, good. So when I first came to US in 2006 and doing my master degree, and the professor is teaching the class, going to the computer, running the code, and doing all of these things. So one student said that, suppose, professor, there is a nuclear war and all electrical system gone, there is no computer, there is no software, how can I compute this thing? So professor said that, well, let me explain these things to you in next class. So next class, he brought all the mathematics that are lying behind that. He wrote these things and show a simple example. So this is the simple example. That's the way it was played. Understand? So the normal table that you have seen in there, British government, it's called Royal Statistical Society. There are a lot of people who are hired there together, and 200 years ago, they are sitting in a lab and they are paid by the government. They are doing paper and pencil, all of those numerical computations by paper and pencil and eraser in order to minimize the error and finally this table. So a lot of people work on that table. The table that you are saying, It was created 200 years ago or more than that. Okay, and a lot of people. Now this computer is in there. I write the function, I write the algorithm, I run it. It is coming, right? During that time, there is nothing is in there. So down the road, if you see some log values, how the log value, log of 102 equal to what? These things. Log value, the exponential of -5 equal to what? There is this table as well. Okay. Okay, now the inverse problem. What is the inverse problem? Inverse problem was also found 93rd percentile of the SAT score. So 93rd percentile of the SAT score. So that means this you have to find probability of X less than A equal to 0.93. 93rd percentile. Clear? 93rd percentile. 93rd percentiles of the SAT score. So this is the figure. This is equal to A. This is equal to 0.93 and that is equal to 550. Drawing graph will make you perfect to understand what's the rationale for solving the problem. So you take the SAT exam before getting admission to the college, right? And then you write in your application packet, my SAT score is 87 percentile, 42 percentile, 93 percentile, something like that, right? So what would be the? So the answer is this. It is just this. A equal to states dot norm dot PPF 0.93 550 20. That's it. Clear? If you again ask me, I want to do these computations by paper and pencil approach. I don't believe on the computer. So again, what you'll have to do, let me write from here to there. Suppose you asked me, I want to do these computations by paper and pencil approach. So let me show you how to do that from here. Probability of X minus mu over sigma less than A minus mu over sigma equal to 0.93. Paper and pencil approach. So probability of Z less than A minus, here is 550 over 20 equal to 0.93. Okay? Paper and pencil approach, okay? Now what I need, this becomes Z, right? Now 0.93, I have to search for the 0.93. Let me search 0.93. 0.93, I have to search. This is the closest one, 0.93. Are you okay? Paper and pencil approach. This table is provided 0.93. Clear? So corresponding to that, what is the value? 1.48. 1.48. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means we have 0.93. We have 1.48. 1.48. 1.48. 1.48. So now I can compute that A 5 minus 5. A minus 550 over 20 equal to 1.48, right? Now find the value of A. A equal to 1.48 times 20 plus 550. That is the answer. Paper and pencil approach, okay? Are you getting it?
Got 579.
579.6. Okay. Now let me find it by using Python, okay? 579.6. we want to find it by using Python. So come in here. Here. This is equal to 0.9393 and mean equal to 550. Standard deviation equal to 20 and rest of the thing as it is. 579.51. Agree? But you have a freedom to use. You have a freedom to use either Python or paper and pencil approach or table approach. Okay? Are you understanding? How are you, quite well? Are you okay? You're good? You're okay, right? Good. Okay. Now there is another topic. After finishing that topic, then I will go for Poisson distribution. And after Poisson distributions, I will give a brief discussions and go over with your exam. Okay? Okay. Another type of, so we have solved so far 4 types of problem. 4 types of problem. One is greater than, and then number 2 less than, and number 3 between. Take a look. Between, right? This is the between one. This is less than, and this is greater than. Greater than, less than, between. These 3 types, and then we also find the inverse problem. If you want to classify normal distributions problem, there are altogether 2 types of problem. One is straight problem, another one is inverse problem. Straight problem means finding probability, inverse problem means finding the z value. Clear, right? How many types of problem in normal distribution? Straight and inverse. Straight means you are finding probability or percentage. This is called the straight problem. I name it as a straight. Inverse means probability is given, percentile value is given. You are asked to find probability. That is called the, so probability is given, you are asked to find percentile value. Okay. So those 4 types is gone. Now I want to do, this is a sampling distributions problem. Sampling distribution problem. Easy. Okay. Here you will have to find the probability for the mean or total. Let me give you an example. So previous problem, we have mean equal to 550 and standard deviation equal to 20. Previous problem. Okay. So now suppose a sample of 15 students are taken from Macomb High School. Okay. Suppose a sample of 15 students are taken from Macomb High School. Suppose a sample of 15 students are taken from Macomb High School. Find the probability that, mean SAT scores is greater than 550, 565. Number two, mean SAT score is less than 560. Number three, mean SAT score lie between 545 and 555. And number four, find the mean SAT scores at 87th percentile. Okay. Then find the total SAT scores of 15 students. Find the total SAT scores of 15. Find the probability. Find the probability that total SAT score of 15 students exceeds 8,000. Do you understand? After solving this problem, the normal distribution done, then I will go for Poisson distribution. Do you understand these things? Now I took a sample of 15 students, okay, and I want to find their results. Okay, it is the same type of problem. Now it has a different form. Now original mean was 550 and original standard deviation was 20. Okay, this is for the X variable, which is the SAT score, right? Right. Now we have X, right? X bar, which is the mean, right? Which is the mean. What did I say? Mean SAT score, right? Mean SAT score. Find the mean, find the total. Clear? If it is mean, then if it is X, mean equal to 550 and standard deviation 20. If it equal to X bar, then mean is still same, but standard deviation of X bar, it is a X bar equal to 20 over square root of 15. N equal to what? 15. This is the formula, only difference. Are you understanding? So now mean equal to 550 and standard deviation equal to 20 over square root of 15. Clear, right? So now first problem is what? Probability of X bar greater than 565. 565. Okay. So this is equal to what you can write? 1 minus probability of X bar less than 565. So what you are going to do? 1 minus states dot norm dot CDF. Okay, 565, 550. And what should I write about standard deviation? As it is X bar, now I have to write 20 over square root of 15 because 15 students. Okay. Let me solve it. CDF 1 minus 550, 20 over NP dot SQRT square root of 15. That I don't know whether it's math or let me see if it will work or not. And is not finding, so let me see whether math will work. Let me see first whether square root directly work. Square root is not finding. Let me see math dot. Okay, so let me run this import math. Let me see now. Okay, this is the result. Okay.
Change the point.
Oh, yes. Sorry, I'm sorry. It should be. It is 565, right? So this is the answer. Okay. So you have made change only in here. So now the next one. Next one you will do what? Probability of X bar is less than 560. Which states dot norm dot CDF 560 550 20 over square root of 15, which is five 60. Point 97. Four 45 555. 4 545 555, not 445. 545 555, which is states dot norm dot CDF 555 550 20 over square root of 15 states dot norm CDF 545 550 This is what. Clear, right? And then number 4, probability of X bar is equal to A equal to 87%. 0.87. So A equal to what? A equal to states dot norm dot ppf 0.87 550 20 over square root of 15. If you know how to use Python and understand all the problem, whether the problem is a binomial or negative binomial or Poisson, your exam will be just 15 to 20 minutes exam. But I will give you 2 hours, okay? And now finally, that one is total SAT score of 15 to 8,000. So answer my question. X bar equal to sum of X over N. In this part, which one is the total? X bar equal to sum of X over N. Which one is the total? In this case, X bar equal to sum of X over N. This is the total, right? Total divided by N, right? Then you will get the average, right? So sum of X equal to total, right? Right? So the problem is probability of sum of X equal to total SCG score exceeds 80,000. Exceed means what? Greater than, right? Exceeds 80,000. Sorry, 8,000. I have to find this. Are you okay? Are you understanding? Because the question says sum of the SAT score of that 15 students, that means total SAT score of those 15 students exceed 8,000. So this is the formula. So now I can divide sum of X by 15. I can divide 8,000 by 15. Clear? Why I divided it? Because then it will become my mean. It will become my mean, right? So mean greater than 8,000 over 15. Could you tell me the number 8,000 over 15?
It's or 533.3.
Right? And now, right? So now you can write 1 minus states dot norm dot CDF 533.34550 and 20 over square root of 15. So let me finish the discussions of the normal distributions. Ready, right? So let me write here. This is normal distributions, normal distribution. This is standard normal distribution. Standard normal distribution. So this is a mathematical formula. This 1 over twice phi e to the power minus half z square, which you never need to solve any type of problem. You are going to use either table or Python. So this is the twice phi sigma e to the power minus 2 sigma square x minus mu square. Okay. So there are two types of problem, each of these. One is straight problem, and number two, inverse problem. Okay, there is a two types of problem, straight problem and inverse problem. Straight problem means finding probability. Straight problem means finding probability. Inverse problem means finding z value or x value. Okay. So two formula you have to use. One is states dot norm dot CDF. Okay. Here is a one entity, here is another, here is another. Another one is states norm PPF, one entity, two entry, three entry, right? There is also a formula, states dot norm dot CDF, states dot norm dot PP. Clear, right? In the last 1 hour and 15 minutes, I solved this problem. Yes.
So for the zero, I know for the last the standard deviation, the middle one B, and then
Middle one mean, last one is a standard deviation in all case.
okay, so what's the first?
First one is this is if state norm CDF, this is the z value, and this is the percentile value. Mean and standard deviation, x value, quantile probability. Okay. Are you seeing my videos in the YouTube, gentlemen? Gentlemen in the back, are you seeing my videos in the YouTube? Okay. So this is going to be uploaded. In order to do well in the exam, just watch the video again and again, okay? Last distributions that I'm going to discuss now. Maybe this Friday I will make the exam and you have to do it Sunday after this Sunday, okay? Sure. Nowadays, professor can teach a lot of materials because of availability of the technology, availability of this projector and all of these things. And previously when professor teach this, he brought a table when we are a student 20 years ago. So brought the table, go to the student, check this, they are finding, they are struggling. But now it's easier, because if you lose something, if you watch the video again and again, things will be getting there. Nowadays, that is why a college kid is very, very knowledgeable. They have lot of knowledge compared to the other people. Poisson distribution. Is mathematical format like this: x equal to x equal to the power minus lambda, lambda to the power x over factorial x. Okay, this is the mathematical formula of the Poisson distribution, which takes value 0, 1, 2 up to infinity. Clear, right? This is the ugly E. This is called the lambda. This is known as the lambda, I think Greek letter. Lambda. E to the power minus lambda, lambda to the power x over factorial x. You remember I wrote binomial distribution formula, right? And I give the explanations. I wrote geometric distributions formula, mathematical model, probability model, and I gave the explanation. I wrote the negative binomial probability model and gave the explanations. This is the another one. This one actually come from, let me write it, Poisson distribution came from binomial distribution. So there is no rationale. There is no intuitive explanation. No intuition will work to understand the probability model of this. Why this? Why this? If you want to intuitively think, if you want to apply method of induction, those are the process, if you apply to understand the mathematical model, that will not work. Clear? You understand what I said? So suppose if you want to use all of your brain to understand this mathematical model intuitively, you want to understand this model by method of induction, that will not work. Because of what? Because this model is pure mathematical derivations come from the binomial distributions. This is the binomial distributions probability of x equal to x and cx p to the power x 1 minus p to the power n minus x. Okay, from there two condition has been applied. What are the two condition? Condition is n goes to infinity and lambda equal to np. This condition was used. N goes to infinity, that means number of trials goes to infinity and lambda equal to np. When these things was plugged in there, lambda equal to np, so p equal to what? P equal to lambda over n. This p has been plugged in there, and then mathematical manipulations on limiting scenarios was applied, and from there it has been obtained. Clear, right? No persons on the planet on Earth, or no persons on this planet, no person on the face of the earth can connect these things intuitively or method of inductions that, well, this is the rationale, this come to that, that's come to that. No, it will not work. How? Why? Because this is a pure mathematical derivations. These two conditions are applied on these, and then limiting case was taken, and then finally beautiful format come into an existence, and they name it as a Poisson distribution. Okay. Now, where to use Poisson distribution? Where to use Poisson distributions? Under two conditions, Poisson distributions will be used. Condition 1, n equal to number of trials. Number of trials is large. Okay. N, which is equal to number of trials, is large. And number two, P, probability of success is very small. Very small. Why? See, lambda equal to NP is taken, then P equal to what? Lambda over N. If N goes to infinity, that goes to 0. If N goes to infinity, that's the rationale. Example. I have to give you an example of these two things. Then I'll go to the problem. Then I go to the problem set. There is this Chandler Park at Macomb, right? Chandler Park. You know that, right? Chandler Park. So in one day, one working day, how many car passes that? Maybe 100,000. How many accidents takes place? 1, 2, or 0? So N is very large. How many cars? 100,000, right? How many accidents? 0, right? Are you seeing these things? Probability of accidents is very small, right? How many cars? 100,000. That makes sense, right? Real life example, right? So in a telephone exchange, how many calls come that are totally irrelevant? Okay, or how many phones call come that after one ring that's cut off? Maybe undergraduate admissions, they got each day maybe 500 phone call. Okay, so then maybe 1 or 2 is dropped or missed call, something like that. So you got the real life scenario, right? So the scientists, the mathematicians, each came to their head, and they one day a person wake up from the sleeping, he write the binomial distribution. He said that, well, I want to make number of trials n equal to very big, and I want to keep the mean as the same, lambda equal to NP. And then I want to plug it on the binomial distributions, and all the mathematical rules of limiting scenarios I am going to apply. Let's see what I find. And then he found that. Okay. Now I'm going to solve a problem. Do you know Roman Empire? Even nowadays, people ask question to the history.com how Roman Empire fall. And even to nowadays, okay? It's a very big empire. And on this planet, there is some rules, like there is a certain time for one empire. So Roman Empire, Persian Empire, and British Empire, now American Empire. You understand? During the Roman time, a person's make a study or like similar to that, or maybe another. How many soldiers died because of the horse kick? Do you understand? That should be very small, right? So this is a real example I am going to give. He studied 20 army corps. 20 army corps. Okay, for 10 years. Okay, so that means this is a 200 years of, if 20 army corps each 1 year, so that means 200 years if you put like this, or 200 observations. Okay, 200 observations. So what he found that on an average each year, on an average each year, 0.61 soldiers, DIERS, on an average. Is the spelling right or not? The soldiers are spelling wrong, right? Is right? Okay. Okay, so he find that on an average each year, 0.61 soldiers died. Because of horse kick. Okay, so that 0.61 is our lambda, that is the rate. So are you seeing this is the mean, right? Lambda equal to NP. A binomial has a mean NP. So that is the rate. Lambda is the rate of the Poisson distribution, which is the mean. Because NP is the mean of the binomial distribution, which I discussed. So lambda equal to this. Now, I want to find these things. Find the probability that in a year, exactly two soldiers died because of horse kick. Number two, more than two soldiers died because of horse kick. Less than two soldiers died because of horse kick. Clear? So now let us solve the problem. Then we will go for the Python as well. Then I'll give the explanations. Number one, exactly two soldiers. Probability of x equal to 2. X equal to 2 means e to the power minus lambda equal to 6.1. 6.1 to the power 2 divided by factorial 2. Okay? So now I want to compute those things by using Python. Let me see. Math dot exp dot 3 equal to what? Good. So now I want to find exp to the power 0.61 and then times it will lambda to the power x 0.61 to the power 2 divided by 2. What? 0.61, that does not work. I have to put, yeah, 0.3224. Okay, so let me 4 to the power 2 equal to 16. Yeah. So then our answer is 0.3224. 0.3224. Answer is 0.3224. Clear, right? Do you need to see the Python code or not? Here is the Python code. You got it, right? Okay, I'm going to the next one then. Next one is more than 2. So probability of x greater equal to 2, which we can do 1 minus greater than 2, more than 2. So 1 minus probability of x less equal to 2, right? Which I can write 1 minus state dot Poisson, if I am correct, then CDF equal to 2. And then I have 0.61 is the rate. Let me see whether it will work or not. Otherwise, you have to search. States Poisson, Poisson, 1 minus, and then I have to change it here. And then that is equal to 0.61. 6, 1, let's see. Psi state has no attribute Poisson. So then what is that? It Poisson states Poisson CDF. So what I'll have to do? Could you find for me? Python code for finding Poisson probability. Find for me, please. Help me. Python code to find Poisson probability. Let's see if it is. Yep, I found it. It's just Poisson. Okay? It's just Poisson. For example, if I want to find is PDF, let me see PDF. This is what we have. Let's see if it is PML. I'm trying to finding another thing. Okay. Uh, 2, 1. Exactly 2. Why these results are different? Did I make something wrong? Take these things again. Lambda, right? 6. Let me do it another way. Oh, I made a mistake maybe. To the power minus lambda times. Formula is right. I made a mistake because I did not put the negative sign. To the power lambda to the power x 0.61 to the power 2. Now I think I will get the result. Yep. Okay. Okay, let me clarify one thing. When take a look at the board. When I plug these things in the Python, I did not put this negative sign. So that is why I got this value. Actually, this value is wrong. Are you understanding? When I manually compute the Poisson probability of having exactly 2 deaths by the horse key using Poisson distributions, I forgot to put the negative sign. So that is why the probability is 0.3224. But when you put the negative sign, then it will be actually probability 0.10. 0.10. How can I find that? This is the formula. Write this formula, please. See, this is the formula. In order to find exact probability, previously we do CDF and PPF, right? Now you have another formula, PMF. Are you seeing PMF? Okay, this is the exactly. Understand, right? So altogether 3 type of formula we are going to use: PMF, CDF, and PPF for the binomial, for the negative binomial, for the geometric, for normal, and for Poisson. Okay. Clear, right? Okay. So now then this should be what you can write here. You can write here 1 minus states dot Poisson. I think all small letter dot CDF, and then you can put here 2,61. 2,61. 2,61, yeah. For this one, you can put here states dot Poisson dot PMF 0.612. Sorry, 2.61. This is should be 6.1. This is should be 2. This is the way you can directly find, okay? And then less than number 3, x less than 2. So then probability of x less equal to 1, which is equal to states dot Poisson dot PMF, sorry, CDF 2,61. That's it. Okay. Okay, so let me do a quick thing. So discussion 1, your next exam will be from binomial. Number 2, geometric. Number 3, negative binomial. Number 4, Poisson. Number 5, normal distributions. And number 6, sampling distribution. Okay. Is 6. Please pay all of your attention for the next 5 to 6 minutes. Okay. Are you ready? Ready, everyone ready? So for the normal distributions, sampling distributions, and there could be standard normal distribution as well. Okay. What are the formula you are gonna use? You are gonna use states dot norm dot CDF. Okay. And then 1, 2, 3. This is mean, this is standard deviation. Here you are gonna use states norm dot PPF, quantile value, mean, standard deviation. And there is also normal distribution. There is also in the 7 you can put here. There is also standard normal distribution. My goodness. What happened now? Okay. These are the things. And here is also, there is a For some reason, after a certain time, I have to close it. Okay, how do you know a problem is a binomial problem? Number of trial is fixed. A hospital has 20 patients. Okay, a coin is tossed 10 times. A die is tossed 15 times. 20 students take an exam. Understand? Number of trials is fixed. Okay, success probability is given. Okay, and then you will be asked to find the probability of happening exact success, at least success, at most success. So three types of binomial problem you will get: at least success, at most success, or exact success, right? So how do you know a problem is a binomial distribution problem? By reading the questions. What are the conditions? Number of trials is fixed and probability of success is given. Clear, right? Okay. Geometric distribution is the most easiest distributions. All of us in our life, we are using geometric distributions, right? One success, one college admission, one college admissions. First one means, second one means, Harvard means, MIT means, and then University of Chicago, right? So you are pursuing to achieve one success. Most of the time in our life, we are happy with only one success, right? One college admission, one job, good job, and one home, one car, one spouse. So by reading the question, if you see, the problem is telling you until I get the success, until I get the success, until I get a success, one success. Those are the geometric distributions problem. What is the negative binomial distribution? Instead of one success, you are looking for a specific number of successes. Okay? This boy invited me, my wife, and my two daughters at his home for dinner. And I told him I like salmon fish. And he was looking for 4 success. He went to the river and tried to catch 4 salmon fish, right? 4 salmon fish. But that is coming, the success coming, failure, failure, success, failure, failure, success, success, failure, 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 success. So data is generated in a series of failure and success. It is not binomial one where all the trials is in there. So a hospital has 10 patients. See the close by itself, the Word document. So binomial one, all the. So in the pond, there is a 20 salmon fish. I want to throw the net, I want to get 4. Okay, but the negative binomial, no. You are searching one by one until you get the 4. You understand? So my experiences is telling me student messed up with the binomial distribution and negative binomial distribution. I'm giving you warning, okay? So binomial distribution means what? Everything is fixed. Number of trials, number of fixed. But the negative binomial distribution, you do not know how many times you have to put your angular to get the result. That is coming failure, success, failure, success, 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 failure, 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 success. Once you get the 4th salmon fish, then it is done. So I discuss binomial, geometric, negative binomial. Poisson distribution is what? By reading the questions. Number of trial is very big. Very big. So Roman Empire has how many soldiers? 100,000 soldiers, right? So on an average, 0.61 soldiers got killed by the horse kick. So number of trials is very big. By reading the question, you have to identify whether this is a Poisson distribution or not. When you see n equal to very big and success probability p is very small, in that case, it is Poisson distribution. And normal distributions, I already discussed. The word normally distributed must be in the question. Okay? Because there are other continuous type distributions. That distributions can follow, like the variable can also follow that distributions. So clear, right? Any question? Okay. If you do not have any questions, let me go to your exam now. You understand? Okay, so let me go to the D2L. D2L. I'm recording, but for a time, I just want to. Your name is Clary, right? Clary Higgins, right? So now let me go there. Screen. Okay, this is the exams of the Clary Higgins. Sorry, I mispronounced your name. Clary Hennis, right? Hennigas. Clary Hennigas. What cultural background? Is German name?
Yeah.
German? Okay. 300 years ago, your forefather came? 400 years ago? 200 years ago?
Before the Civil War.
Before the Civil War. So that means something like 1850, something like that, 1840. Okay, so this is the question. How many sample points in a sample space when 3 die and 4 coins are tossed together? Okay, so this is the answer. 3. Let me bring it in there. 3 die and 4 coins. 3 die. So 3 die and 4 coins. Okay. Did I? No, I wrote it other way, right? It should be 6 to the power 3, right? It should be 6 to the power 3 times 2 to the power 4. 3 die and 4 coins. This is what? PPC, right? Basic principles of counting, right? This is BPC, basic principles of counting. How many ways the letters of the word Mississippi be arranged? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is, this is number 1. Number 2 is 11 permute 11, which is equal to factorial 11, right? Right? How many distinct ways the letters of the word Mississippi be arranged? So factorial 4, factorial 4, factorial 2. So there is, so number 3, this is factorial 11 because there is a 4I Mississippi. So there are 2P and there are Mississippi 4S. Okay? 4I, 2P and 4S. So number 4. Seven white balls, 6 black balls, 4 red balls, and 3 pink balls. So that means 20 balls. How many ways 5 balls can be picked? That is 20, choose 5. Okay. Then number 5. Find the probability of all 5 balls are white. So all 5 balls are white. So 7, choose 5. 20, choose 5. Find the probability. Number 5. Number 6. Find the probability that each of the 4 balls are from each color. There are 4 colors, right? So that means 7, 6, 4, 3. It should be 20 choose 5, 7 choose 1, 6 choose 1, 5 choose 4 choose 1, 3 choose 1. 7, 6, 4, 3. 7, 6, 4, 3. That is the way. This is the multiplication. Number 7. A complex radar systems with 2 units work to detect missiles. The 2 units work independently. Are you seeing the word independently? That is multiplication, right? Each has chance of detecting missiles like this. If a missile is launched, find the probability that both units detect the missile. So that means they are independent. What I am asking here, probability of detecting by first missile, both unit detecting by the second missile, which is equal to probability of D1 times probability of D2. Why? Because of the word independence. Are you seeing the word independence? Okay, so that is the reason you have to put here 0.90 times 0.80. Very important concept. Independence is a very important concept in statistics. Okay, independence is a very important concept in statistics. Non-units detect. So non-units detect means what? Probability of D1 complementary, no detect. Probability of D2, no detect. So that means 0.10 times 0.20. If detection is 0.80, non-detection is 0.20, right? Right? If detection is 0.90, non-detection is 0.10, right? See, if 2 events are independent, then all of their other categories are also independent. Let me write it for your future. Suppose A and B are independent. A and B are independent. This is the sign of the independence. This is the sign of the independence, okay? Then A complementary, that means not happening A and B also independent. Then A not happening B complementary also independent. Then A complementary and B complementary also independent. So A complement means not happening A. Probability of happening A, not happening A. So this is, remember these things in your life, okay? If 2 events are independent, all of their combinations are also independent. So that is gone. In a small village, there are 300 people. 200 of them are young and 100 of them are in good health. 130 of them are young and poor. So let me do these things for you. I need 1 page. Insert. Come on. Insert. I have to do these things. Young and adult, right? Health. Good health, bad health. Let's see, let me read the question. 300 people, 200 of them are young, 100 of them are in good health. 200 of them are young, 100 of them are good health. So that is 300, so that means this is 200. And this is 100, right? Right? And then after this, 130 of them young and with poor health. Young with poor health. Young with poor health, bad health, poor health, 100 of them. So this is 100. Sure? What did they say? 130 of them are young and with poor health. 130. So that means 130. So this is equal to 70. and that is equal to 30, and that is equal to also 70, right? Right? Then, if a person is randomly selected, find the probability selected person is a young or in good health. Young or good health. Probability of young or good health, right? So probability of young plus probability of good health minus probability of young and good health. So probability of young equal to 200 over 300. Good health equal to 100 over 300 minus probability of young and good health 70 over 300. That's the answer. Right? I solved this type of problem in the class. This is the problem number 9 and problem number 10. Randomly selected, find the probability selected person is in poor health condition. Poor health conditions. Poor health condition equal to 200 over 300. Right? So in order to do you have a final exam, and then you have this exam coming from these 5 distributions: binomial, geometric, negative binomial, Poisson, normal. Normal has 3 types: standard normal, where Z, and then X, and then X bar and total, right? So for the normal one, you have remember these things when you plug the value. Normal one, you have Z, you have a X, you have a X bar, you have a total. Okay? Each of these has a 2 types. One is straight, another one is inverse, right? Normal distribution, how many types of normal distribution I have discussed? 4, right? 4, right? 4. One is Z, one is X, one is X bar, another one is total. Each of these has a straight and inverse problem. The name straight and inverse, I name it, but you will not find it in the literature. They do not call it as a straight. A straight means Z value or X value is given, you are asked to find the probability. Inverse means exactly opposite. Probability is given, percentile value is given, like percentile given, and then you are asked to find the Z value or X value. Okay? Any questions, comment, problem, personal problem that you want to ask?
Can you release our score so we can see what we did wrong last?
Can you see your score or not?
Oh, you can see it. I can just see what percentage I got wrong.
Okay, I'll release that. I'll release that. Okay, if I do not release these things by tonight, one of you email me, okay? By 9 p.m. because now daylight saving time changed. I go to bed 9 to 9:30. I can work whole day, but I cannot work at late night. Some people, they study at late night, but I cannot. My brain does not work. I love sleeping, okay? Have a good day. See you in next week.